Video number 98, Pascal's Triangle. Pascal's Triangle. This is what we do for Pascal's Triangle. At least this is what was discovered when Pascal was looking at raising binomials to various powers. If you take x plus y to the 0th, I think everybody can agree that's 1. Anything to the 0th power is 1. Now, x plus y to the first, that's simply x plus y. We're all set. X plus y squared is going to be x squared plus 2xy plus y squared. Alright, and you can work that out. X plus y to the third power is going to be x plus y times x plus y squared, right? That's this. If you were to distribute each of these and add like terms, you're going to get x cubed plus 3x squared y plus 3xy squared plus y cubed. Alright? If you did x plus y to the fourth power, quantity to the fourth power, you'd have x plus y times this. If you distribute x and y, add like terms, you're going to get x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. Now, as it turns out, each of these coefficients, alrighty then, if you were to take these coefficients 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and put them in a triangle, Pascal's triangle, we would notice a pattern. The pattern is 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 5 is 6. Do you see the pattern happening here? This would be 4 to the 0th power. Alright, the next one is x plus y to the first. So it doesn't go 1, 2, 3. It goes 0th power, first power, second power, third, fourth, fifth, sixth, and 7th. Now, if you were to be asked to do x plus y to the 7th power, this is no longer a question that takes us a very long time. We do not need to do any more algebra, at least in this form. What we are going to do here, ladies and gentlemen, is Pascal's triangle. We're going to go to the 7th power, 0th, 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th power. These are the coefficients for x plus y to the 7th power. So therefore, the correct answer to x plus y to the 7th is x to the 7th plus 7x to the 6th y, okay, plus 21x to the 5th y squared plus 35x to the 4th y cubed plus 35x to the 3rd y to the 4th plus 21x squared y to the 5th plus 7xy to the 6th plus y to the 7th. Now, how do we know what to use for the exponents? Well, if you go back to the first page, bam, you will see that pattern occurring right here. X to the 3rd, then x squared, then x, then no x. You have no y, then you have a y, then you have a y squared, then you have a y cubed. You have an x to the 4th, x cubed, x squared, x, no x. No y, y squared, y cubed, y to the 4th. Notice here, 2 plus 2 is 4th power. Notice here, 3 plus 1, because that's y to the 1st, right? 3 plus 1 is 4. So you're always going to get your 4th power. Therefore, we will always get, bam, our 7th power here. 7th, 6 plus 1, 5 plus 2, 4 plus 3, 3 plus 4, 2 plus 5, 1 plus 6. Bam, 7. Now that leads us to another problem. What if we were asked to do 3x plus 2, bam, to the 4th power? Okay, I just changed that 1 to a 2 here so that we can do this. Alright, Well, Pascal's triangle to the 4th degree, 0th, 1st, 2nd, 3rd, 4th degree has 1, 4, 6, 4, 1. So we're going to use 1, 4, 6, 4, 1. 1 times the first term to the 4th power with no 2 plus 4 times 3x to the 3rd power times 2 to the 1st. There's your 3 plus 1 is 4th power. 6 is the coefficient in front of 3x. 3x squared times 2 squared. There's your 2 plus 2 here is 4th power. Then we're going to use a 4 for the coefficient. 4 times 3x to the 1st times 2 cubed. 1 plus 3 is 4th power. And then plus 1 times 2 to the 4th. Well, 4 times 3 cubed times 2 is 216. 6 times 3 squared times 2 squared is 216. 4 times 3 times 2 to the 3rd is 96. And 2 to the 4th is 16. So therefore, 81x to the 4th plus 216x cubed plus 216x squared plus 96x plus 16. Ladies and gentlemen, you have Pascal's triangle.